Hello, I am Tim Allec, junior computer science major.
My name is Macy McKenney. I'm a junior and I'm also a computer science major.
My name is Wyatt Bodle. I am also a computer science major.
My name is Vincent Melara. I'm a junior and I'm also a computer science major.
And this is our machine programming presentation for EGR 329. I hope you enjoy the presentation.
Background of machine programming. What is it? Machine programming is automated development and maintenance of software. This refers to the process of using computer programs and algorithms to create, update, and manage software applications without extensive manual intervention. This means we can write software that can write other software. It's essential to understand that this concept is a subset of artificial intelligence. So artificial intelligence kind of encompasses everything, and then within that we have machine programming. How does it work? This technology takes input regarding what a program's function should be. We can have this input come in different forms, so it can be high-level descriptions, requirements, or even existing code. It then utilizes machine learning algorithms to analyze the input, considering both the provided information and some context that we might have. These algorithms learn from patterns in data and determine the next step in writing the program. I'd like to emphasize that it's not just about automating code, but also machine programming makes decisions about software architecture, design, and maintenance that we might not make as humans. What is it not? It's important to stress that automated software development is not always reliable. We see this a lot with like ChatGPT when it writes code for us. A lot of times it is actually wrong. And then also that machine programming is not machine learning. It uses machine learning. Machine learning is a subset of machine programming, but it itself is not machine learning.
So I'm going to be going over a few of the early benchmarks in the evolution of machine programming, a few historical important events. So the first one in 1943, the threshold logic unit, which is the first artificial neural network. So this is important because this model of an artificial neural network, it was very limited back then, but it was one of the first concrete examples of a machine learning model. It demonstrated that machines could be programmed not just with fixed rules, but also with algorithms that adapt and improve their performance. And then in 1950, a few years go by, the Turing test came out, which was a test to, examine a machine's ability to exhibit intelligent behavior. So they were basically comparing machines' ability to compare to like a human brain and how a human brain thinks. This is a big benchmark for what we know now as machine programming. In 1966, ELIZA, the first chatbot, was released. We're used to these nowadays with like all of these chatbots that we use. This is a very primitive one. And then in the next decade, 1970s through the 1980s, machine programming really started to kick off. They were creating programs to recognize and solve problems in like different engineering companies and stuff like that. And then we get to the 2000s, the term deep learning is coined. Now, deep learning is a subset of machine programming that uses deep neural networks to automatically learn and represent complex patterns and features from data. So this is very important when it comes to like data analysis and data structures. And then in 2011, IBM Watson, who is he's a machine AI kind of chatbot. He won a Jeopardy competition against two of like the greatest Jeopardy players ever. And then in 2022, OpenAI was kind of pressured to release ChatGPT for public use, and I'm sure we all know what that is now. And although it was formerly a tool being developed in lab environments, so like machine programming was just like something scientists would work on like under the covers, now machine learning and programming will soon affect many aspects of our culture's daily routines. A few companies involved in machine programming in our modern era involve, of course, OpenAI. Another one includes Google Cloud, IBM Cloud, as well as Amazon Web Services. Just to name a few universities that take a great deal of time into researching machine programming. We have Stanford University, the University of Michigan, as well as Cal Berkeley. Two very important people that are moving machine programming on, and they write books about it, and they do lots of research about it, include Andrew Ng, which is the CEO of Landing AI. He is also the founder of Deep Learning AI, and he is pictured on the left. We also have Fei Li. She is also a computer science professor at Stanford, and she is the former vice president of Google.
Here are some applications of machine programming in everyday life. The first example is Google traffic alerts and maps. Everyone using maps is providing their location, average speed, the route in which they are traveling, which in turn helps Google collect massive data about the traffic, and that helps them predict the upcoming traffic and adjust your route according to it. The second example is online video streaming, which is Netflix. So Netflix algorithm constantly gathers massive amounts of data about users' activities like when you pause, rewind, or fast forward, what day you watch content, and the date and time you watch. And the last example is social media and Facebook. Facebook uses face detection and image recognition to automatically find the face of the person, which matches its database and suggests us to tag that person based on deepface. Here are the 6 sources we used for our slides. The scholarly research I chose was a book called Genetic Programming for Routine Human Competitive Machine Intelligence. This book presents a method for generating computer programs through genetic programming, which is an evolutionary algorithm-based technique. The problem addressed in this paper is the automatic generation of computer programs to solve various tasks and problems. Genetic programming aims to evolve computer programs that can perform tasks autonomously and, in this context, achieve human competitive performance. The authors propose the use of genetic programming, a form of evolutionary computation, to automatically generate computer programs by involving populations of candidate programs over several generations. Genetic programming applies a process analogous to biological evolution, including mutation, crossover, and selection, to optimize the computer programs. The idea is to let the programs evolve to become increasingly better at solving specific tasks. Genetic programming is a relevant technique within the broader field of machine programming. Machine programming encompasses methods and approaches for automating or assisting in the generation of computer programs, and genetic programming is one such approach. It represents a way to automate the development of algorithms and code by evolving solutions from a population of candidate programs. The key results of this research include demonstrating that genetic programming can involve computer programs that are competitive with human-designed solutions across a wide range of problems. The authors showcase several examples where the evolved programs outperform or match the performance of human-written code in various domains. The paper primarily presents an advancement in fundamentals of machine programming. It showcases the capability of genetic programming as a method for automatically generating computer programs that can perform at a human competitive level across diverse problem domains. It highlights the potential of evolutionary computation techniques to address complex programming tasks.
The scholarly research paper that I found was called Visual Knitting Machine Programming. In this paper, the authors take on the issue of machine knitting. Typically, when knitting using a machine, you would have to directly program each design into the computer. With machine programming, this team has taken an interesting approach. They have developed machine programming software that gives a 3D rendering of a knitted design and will write machine code for their industrial knitting machines to take as an input and create the design. I think of it sort of as a compiler from a 3D object to machine code. The results were that they were able to take the time from design to production down significantly, which is the purpose of machine programming. This paper presents application of machine programming in an industrial sense and in any sense where you would go from computer-aided design to machine-level industry code.
The topic of the research paper that I chose is analyzing the pregnancy status of giant pandas using hierarchical behavior information. The problem that is being addressed in this research paper is accurately determining the pregnancy status of giant pandas in artificial captive breeding programs. The current methods are resource intensive and they disrupt the pandas' lives and are also prone to misdiagnosis. The solution proposed by these scientists is an end-to-end intelligent system that uses machine learning methods combined with expert knowledge that is used to predict the pregnancy of giant pandas and estimate the expected delivery date without the need for frequent human intervention or any invasive procedures. So the problem relates to machine learning since they do use machine learning methods to analyze the behavior of the giant pandas and make predictions about their pregnancy status and estimated delivery date. The results of this was that they achieved an accuracy of 91.5% for diagnosing pregnancy, and they had a mean error rate of 0.57 days for estimated delivery date prediction, given that the observation period is 5 days. This significantly reduces the need for human intervention and also reduces the disruptions that's caused to the pandas. And the advancements proposed by this paper applies to machine learning to predict giant pandas' pregnancy status, estimated delivery date, and also advancing performance by incorporating domain expertise. This combination of machine learning application with domain knowledge enhancement can be seen as an advancement to improving machine learning model performance.
The research article I found is in the Neural Regeneration Research Journal, Volume 19, Issue 4. So the problem that the authors were facing in their research was about trying to figure out a better way to timely diagnose stroke and personalize treatment plans and be able to predict the outcomes of those treatment plans. Stroke is a leading cause of disability and death worldwide, so this is an important study for them. The solution was that the authors tackled stroke care challenges by deploying various machine programming algorithms to analyze extensive medical data sets, including images and patient records, to enhance diagnosis, guide treatment, and predict outcomes. The relation to machine programming is the problem of stroke care connects with machine learning and machine programming through the utilization of machine learning algorithms to process complex medical data. Highlighting its fundamental role, and the study illustrates the practical application of machine learning in addressing real-world healthcare challenges. The key results of this research include demonstrating that genetic programming can evolve computer programs that are competitive with human-designed solutions across a wide range of problems. The advancement of machine programming fundamentals for this paper include advancement of machine programming fundamentals and application of using machine programming to solve real-world healthcare problems. So this allows a better bridging of the gap between theory and practice. Some of the key impacts machine programming will have on software development include, well, first off, machine programming will not replace humans. It'll just enhance the way that humans, develop software and code. It'll only shift the way that, software development operates. For example, there will be less time spent on debugging or testing. I believe there will be real-time automated machine debugging done for us as we code. Code will also be easier to compile and run, so less run errors. The machine programming will, assist us with that and give us suggestions from the machine itself before we compile, so there'll be less errors to run into. And then repetitive machine tasks, more tasks will be automated through the machine instead of having us do it manually.
The impact on hardware development. Hardware acceleration is going to be specifically tailored to machine programming, where hardware acceleration refers to using specialized hardware to perform certain tasks more efficiently than general purpose processors. In the context of machine programming, this means designing hardware components will be optimized for tasks related to automated software development. Number 2 will be that machine learning can aid the design and conceptual architecture-based hardware improvements. So sort of the same idea, just with architecture. So we can write architecture using software we've created that will optimize code and kind of tailor it towards your specific goal. Lastly would be testing and quality assurance through machine programming. Programs written by machine programming that can test and optimize software. So we wouldn't have to be writing tests or optimize our software. The machine programming would do it itself.
The impact of machine learning on the healthcare industry. This can include improved disease diagnosis, accelerated drug discovery, personalized medicine, remote monitoring, and epidemic tracking.